Well, bloody hello there, mate. I am not Australian, but today I'm going to talk Australian while I walk you through this bloody problem here for organic chemistry. We got mass spec here for, what is that? 1-ethyl, 1-methyl cyclohexane with a molecular weight of 126, mate, yeah. We got peaks here at 111 M over Z and 97 M over Z. Over Z, that's how you people say it, right? Alrighty, mate. So we need to explain why we see these bloody peaks there at MZ111 and 97 M over Z. Alright, mate. So let's go two ways here. Let's make our I can't even fucking do this voice anymore. So I'm gonna quit for a minute so I can actually explain this, the hard part. We're gonna shoot it with a beam of electrons. We're gonna dislodge an electron and make a radical carbocation. All right, mate, so back to the Australian. So we lose a bloody electron, right? And we get this structure here. And you're like, the bloody hell is that, mate? Well, I'm bloody telling you there's a positive charge and a radical on there. Somewhere on the molecule. That's probably not how they say molecule. Anyways, bloody hell, mate, we're gonna do the same thing here because we need to do two structures. One for the 111 M over Z and the 97 M over Z. I'm really sorry if I'm offending anyone, by the way. I had a little too much goof juice last night. You know, famous last words when you say these edibles ain't shit. Anywho, mate, so let's start with the bloody, let's just draw one of them, mate, because one's the loss of a methyl group, one's the loss of an ethyl. Right, if we do some simple math here, right, 126 minus 111 gives us a difference. I sound like an idiot. Loss of a methyl, M minus 15, right? That could be also expressed as loss of a methyl, CH3. 12 coming from the bloody carbon, the other 3 coming from the hydrogen. Alrighty, mate. So, to draw the bloody hell, this marker dying on me, mate. Anywho, we want to show that we make a radical here, and we make a carbocation. The way that this bond is going to break to give us the loss of the methyl, right, we can just chop it right off. If we break it so we get a carbocation on a tertiary position, that's going to be more favorable, mate, right? So we're going to give the radical to the methyl, right? Radicals, they don't like to be on methyls, but carbocations, they matter a lot more. I don't even sound Australian. Oh, bloody hell, mate. What the fuck is this? Bloody other marker's dying on me. Anywho. Right, so we get this thing, and this thing's going to pass through the detector, right? And it's going to be measured at 111 M over Z, right? Because if we add up all the carbons here, we have 12. 6 there, 2 there, that's going to give us 8. Add up all the hydrogens, 3 right on the end there, 2, 1, or sorry, not 1 there, 2, 2, 2, 2, 2. Let's add that up, right? And we get to 111 M over Z. So that right there is how we make that fragment, and we get a carbon methyl radical. Right, that's the little leaving part that makes it a difference of M minus 15. Alrighty, mate, now let's show the other one, 97 M over Z. Alrighty, if we do some simple math, 126 minus 97, that's going to be a loss of 29 AMUs. Alrighty, so what does that mean? Well, if we add 12 plus 12, indicating 2 carbons, add 2 hydrogens and 3 hydrogens, that's going to give us an ethyl group. So CH3, CH2. Alright, that just looks like this in line angle. So we're losing an ethyl group here. right? That's 29 mass units. That's the difference from 126 for the molecular weight to the 97 m over z peak that we see. Alrighty, so let's get into it. Right here we have a nice little ethyl group, and it's looking like it want to leave, right? So it's just gonna let you do that. Alrighty, so now we get this bloody peak right here. And let's bloody add up the molecular weight of that to confirm that that's going to show up at m over z at 97. So we have 7 carbons, giving us 84 AMUs, and then we add up the bloody hydrogens there, 3 there, and then 2 on each of these carbons in the ring, except for the one with positive charge. Yep, and that shows up at 97. Bloody hell, 97 AMUs for this bloody molecule right here, and is exactly why we see the peak there. So, and I should also say, we get a primary radical right there. All right, bloody hell, guys, that's that bloody problem right there. I have been your Australian American, and I apologize to the Australians that are bloody offended right now. God bless.